This is IBM Museum, and I have that maxed out Model 30 on the bench behind me with a few other items. I'll go through and show a little bit of that and just show a process for a routine that I've got up on the web. And today it was kind of interesting of going through and finding a little error that I had in there. Actually reverse the condition, and I'll go through and explain all that. And I have some links as well that I'll show at the appropriate times. But this is the CheckMCA routine. It's assembly language routine. It's made into a program, and it goes through and checks to see if a system reports itself as a microchannel bus or not. So let me go through. I'll get the internal webcam turned off because I want to go through and just show the layout. It's good that I had kind of the full Model 30 setup out, and I've had to kind of move some stuff around. I was going through and taking or trying to take pictures of Model 30 planers earlier, and I've even got some Model 25, and I've got to do a little bit better lighting. I have that ring light up on top of my camera on the rig. Just needs improvement. But I went through in the being able to run this little utility. I thought that a program that Microsoft included from years ago with their macro assembler, and this is even the 5.1, that there's a program called CodeView, and this diskette has the DOS version. This is Microsoft Macro Assembler, and it's got the Microsoft CodeView for MS-DOS with tutorial on this disk. There's of course other disks, but this is the one that has the CodeView, and this is actually a 360 KB diskette, 5 1/4, and so it's good that I had my good old 4869-001 external drive that's able to read those low density 5 1/4 inch diskettes. Basically, all I did was copy the files. I mean, it was that easy for that time frame to copy the files of this diskette over to a directory, and I'll show that that structure of what I've got set up in a moment. But I'm going to go through. I've got the system set up for video capture, so I'm going to get switched over to it. And we'll actually run through. You can see the access lights. I just did a warm reboot. We're going to see the system fresh. I'll actually come back on the screen for part of this and really have my back to the camera for the portion that it won't interfere with what I'm running. And later on, when I need to get off screen, I will do that to show the CodeView program. So and one of the first things I'm going to do here as well is I'm going to run the mouse driver. I don't have this set up in autoexec.bat. We're just going to get it loaded for the benefit that it's going to help under the edit program. And even though I often use the shortcut keys so quickly on that, and also the CodeView program is a full screen debugging utility, or you're able to see as it runs through the code. So the first thing I want to show is we're going to look at the program that I have set up. And it's actually a script. This is a script file. And by convention, is this SCR for script file. I'm going to run the edit program that MS-DOS has. I think this is 6.22 that's on this maxed out Model 30 on that big 1 GB hard drive. So I don't have a scroll wheel on my mouse. Of course, I have arrow keys. As I say, I'm used to the keyboard so much to go through and navigate through the on-screen, the full screen editor in this case that is with MS-DOS. And so this is a script that we have and we're going to pipe this through debug. And I'll show where I have this online as well, and in a sense, in a routine form. And the working program in this case is just a little bit different and compiled. And actually is effectively, there's some shorter code that's able to be done to get this into a working program in this case, able to run rather than what the routine demonstrates in a way. So let me show that where that and that listing on the web, and I'll include that in the video description, has some, okay, and I'll get myself out of the way for that. So this is a routine that I have up there, and it's the same thing. It's named as CheckMCA, meaning MCA meaning the microchannel, and this routine checks to whether the system has a microchannel bus. Now, this is pseudocode. This is effective code that you still have to go through and put some details in, as far as if there's like back-to-back IO reads and stuff like that, you've got to go through and allow the system to basically catch up with those IO reads. So you do you basically read a dummy port. I don't have a lot of that incorporated in here, just for the routine to be somewhat clear. And scrolling through it, and again, I'll include the link so people can look through and kind of see what this routine does. Now, for all that, this will be the code that I have. I'll demonstrate in a moment. By and large, there's some extra sections in there as well. And there's even an additional portion at the bottom that's kind of extraneous to this particular program on the that will run. We just want to tell if the system has a microchannel bus or not. And the lower portion of the routine, the slots, that actually goes through and even figures out the total number of microchannel slots that's on a system, just being aware that some of the slots effectively that can be on a system, and there's a note at the bottom of this, and then I have the information at the top in the header. There may be planar resources that are identified as a microchannel slot on some systems, like video or hard drive controllers or something like that, that are built into the planar, can be identified on these slots. I even have another routine on there, and then at the bottom of this page, it has a back to the routines index. I've got just a few routines there. I've also got one that searches for a particular adapter type, microchannel adapter type, on the bus of that system. In other words, if you have like you're wanting to check for a sound blaster or in microchannel form, it goes through and you plug in the values for that, and it goes basically searches for that adapter type on the system and reports the first instance of that. That's another program or another video I can get into at another time. So this routine goes through and actually calls it calls a function, or the get configuration. And I'll bring that up just briefly, just to kind of show what we're looking for there as well. So this is a BIOS function call, and it's interrupt 15 hex function C0 hex. And this has been included on every system except the very early IBM PCs. And it goes through a convention. I'll include the link in the video description as well. Just what this reports back. You can run this routine in a program, and it'll go through and respond in a particular way, telling what's on the system. Like if it's got a real-time clock, It's got a second interrupt controller, extended BIOS data area. And as we see kind of in the middle there, we've got this feature byte 1, and bit 1 is marked out as bus is microchannel. And I've just basically repeated as I go through and have it as two separate words, microchannel, just how it's utilized sometimes out there on the internet. And then the bit 0 below it is a dual bus system, and we can go through and check for that. There's other systems that IBM systems that can report a dual bus, that one of those buses may, the thought is it's additional bus to microchannel or something to that effect, or it has both PCI and ESIA, or it's a PCI plus microchannel system. We'll look at that in a little bit more detail, but that's the get system or get configuration returns what's called the system descriptor table. Okay, so here back within the script that we're going to use to assemble we're going to assemble this, use the DOS debug to assemble a program from the script. And we do have, you can see some areas in here that there's a, that there's that move AHC0 and interrupt 15, and that is that BIOS function call. And just as it goes through and tests some of the conditions for the responses from that, going through and testing it. And of course, it doesn't have that slots routine in there. But as I say, I normally I'm used to even using the keyboard. I just do, I'm making changes to the file. I just do an Alt FS and then Alt F exit. That's a save file and then exit. I'm so used to knocking it out. So what we're going to do here is we're going to run the debug, the DOS debug utility. We're going to pipe in this script. And that script file basically has just all the commands that debug is going to act on to make that, to wrap up that program or assemble it for us. And so going through, and we didn't get any error output or anything like that. It has gone through and, given us a listing of what this unassembled or the human readable contents for that, for all the I'm not even, I'm going to struggle with pronouncing that word in the condition I'm in. But we've got debug that made, in other words, we could go through and I'm just using capitalization here just to kind of accent that 8.3 file naming convention. Actually, we want to do the COM program. Okay, so it shows it's there, and it's all of 35 bytes long. And of course, it takes up a whole sector on the disk. But it's, in a sense, very compact code, and really for a workable program, you'd even include some output and some information as it runs, rather than just the basics that we've included here. Now I've got the code view stuff in its own directory, and we'll do to execute the code view program, it's CV, and then we're going to point to where the program that we want to kind of run through step by step. And that's in the root directory of the C drive. Okay. And that's what shows. I'm going to have to go through. I will hide myself here, and I'm going to go through within the program. As you can see, we have mouse effectively there to go through, and we're going to turn on view. We're going to go through, and that's a shortcut key of registers. Okay. Now for the output, we could actually be writing strings up from the program as well into effectively what would be DOS when it runs. And I had to get my picture out of the way because those registers are shown over on that right-hand column. And those will go through and change as we run the program. Now, under the run menu, we actually, in this case, want to choose execute because that's a statement by statement execution. And it actually jumps into the BIOS routine at some point for calling that get configuration BIOS call. But let's go through and do an execute. Okay, and the reason I was quiet as that ran is that you may have to go through and actually play that at a slower speed. In fact, I'm going to get back out to, let me get back out to the just DOS in this case. And I'll go through and change back out to the directory for what I can show in just a moment. But let me get back on the screen. Okay. And in this instance, it actually, once the program completed, it gave that, the 0 in parentheses. And as I said, I didn't speak during that because you may want to run that section of the video at half or even quarter speed. If I talk, I'm going to sound drunk. But you're able to do that just to kind of see that execution. And you'll see for part, if you keep track of things, you'll see the code of the program. And then when it makes the BIOS call, it actually jumps to another area and quickly kind of goes through all that stuff. And that's to get that system configuration, that system descriptor table from that get configuration call loaded in to a little spot in memory to where it can go through and execute. And what I can actually do is that system configuration call, it actually goes through, and let me bring up kind of my note here. What we want to do is we want to get back into debug, and we're going to do I'm going to do a dump F000 colon E6 F5. And we're going to do a length of A, which is 10 bytes. Okay, when we press the enter key, this is actually where that table is in the ROM BIOS. And showing the length of 8 bytes and going through and the information that's encoded in there. And actually that area that has that B4 actually contains the contents for the get configuration. What I'll do is I'll bring that back up on the screen. I can probably still just leave myself on the screen. Let's get interacting with things. But that's the information that's returned. You see that it's got an initial word of the number of bytes following, which is marked here as 0800. That's a word, and it's the most significant, or excuse me, the least significant byte is first. So it's ultimately a word value or the contents of a data word with the just 8 in there for the length of the table or the number of bytes that are following. And the information there about can be decoded about the submodel or model and submodel encoding, the BIOS revision, the and then we have that feature byte, and that is where that B4 data is. In other words, DMA channel 3 is used by hard disk BIOS. The real-time clock is installed. Here it shows, of course, as the second interrupt controller is not installed on the MAL30. That just has the 18259. And then the interrupt 15 function 4F called on interrupt 09. And I'll have to look at that, what exactly that is to that. And then for the, it was B4. So then from there, we have just the fourth, that bit 2, being that extended BIOS data areas is allocated. And then all the other things, such as wait for external event and bus as microchannel or dual bus system, those bits are cleared in this instance for that B4 result. And so let me get that off the screen. Now, one way, and that's Q for quit. And what we're doing by setting the AL register to 1 if it's a microchannel system, or it just be 0 if it's not a microchannel system. There's a batch file that I've got set up kind of to demonstrate that. And I go through and I call that, I named it check error, because it goes through and actually checks the error level once that program terminates. And in this instance on the MAL30, it's showing as 0. And here's the contents. Return echo off. And I'm not concealing any text, at least in this case. It finishes that. But it runs through and it runs that CheckMCA program. And then if error level 1 or equal to 1, it actually writes on the screen, this system is microchannel. And so if we go through and run that batch file, it just comes back. There's nothing that says, hey, the system is is microchannel. It doesn't have that echo to the screen. And certainly with this program, we could go through, it's going to take up the same space on disk anyway, that we could make it bigger. And that's the thing, is to go through and at least list some output and, when it was written and everything else. You can go through there and fill in a lot of details, have strings displayed for the program to tell what's going on, what it's doing, and it echoes the information to the screen. And even could go through, I could have in that batch file just an else. The system is not a microchannel system, something to that effect. But that's really kind of a broad overview of going through, having this routine. I'll list that on the video description, and making a program out of that code, then, or writing a script to run through debug, and piping it into debug, getting a executable program. And then you could, I use the code view to go through and check how the program is running. There's later versions of code view that were, of course, a lot better and easy ways to, and of course they made a Windows version too for the Windows programs. But these utilities are typically in that COM format. And the reason that debug was used is that the book writers out there, viewed it as if people had DOS, if they had the full DOS version installed on their system, and of course, typically on the hard drive at that time, even the small hard drive, that they had the debug utility that was included with DOS, and that they could go through and write a script and pipe it through debug just to do a couple utilities. And I've got a few books on that. That's how I got started in assembly language too. It's just these little utilities. Now we didn't go through. We didn't really see the true results here. What I want to do is it'll probably be a lot shorter video, but once I get situated and get my maximal 30 away, I get a microchannel system back up here. And probably the closest at hand is that Model 80 case with the Reply turbo board in there. I need to go through and test some cache for friends, of course, that they've got that system with that planer in there, that nice fancy planer in there, but they don't have the cache. And I've got a few extra cache. It's different from what I've got installed on my machine, and I've had reports that it may not necessarily run very good. In fact, I've got what's called a Pod 83 or Pentium overdrive processor, or Intel called it the Pod for 486. That is it's got Pentium level, and it goes into those socket 3s, and in fact, I think it went into all the socket types of socket 1, socket 2, socket 3 that Intel had, effectively that for the zero insertion force, those seat in there. And it goes through, and the pod can have that CPU can have a little bit of issues a lot of time with the L2 cache that's in the system. So I want to go through and test that and see if I can get that right. And I'll send that cache to them if it passes my test and looks like it'll work for them. So if you thought that this video was informative, and just wait for that where I'm able to run this utility on a microchannel system, but we can see that how that branches through there. Just wait for it, but click on the like button for this one if you enjoyed this video, and subscribe to my channel if you've not done so already. Recommend it to your friends so they can subscribe too. But that's all I have for now. This is IBM Museum. Thank you.